All right, class, welcome back. And this is the series on 12 leads, and this is the second part of it. And that second part has to. I want to make sure that you guys understand what you're looking at. Oh, I have disappeared. Okay, now I'm back. I don't know what happened to my guy right there. The long and short of it is, I want to make sure that you're understanding what you're looking at when you're looking at a 12 lead. And there's some things that you definitely need to know, where the unipolar leads are, where the bipolar leads are, where the precordial leads are, how those relate to those strips that are up underneath it. How do you make sure that you got it on right? And then we're going to talk about converting milliseconds to seconds, and we're going to locate the isoelectric line. And it's kind of important that, so this is a kind of a standard printout for the hospitals. With that being said, there's a couple parts I want to make sure that you know. This here, let me grab my pen here, and this right here is what we normally see with our standard LifePak 15. Okay, and it's very important to understand those things, that we're not going to get that strip up underneath it. But I will tell you that the same principles apply no matter what machine you're kind of using. Again, most of the hospitals have some sort of lead. They do different leads. It depends on what it's preset for, what the cardiologists kind of prefer. Now, again, it's really important that you understand that these are continuous, but they're not simultaneous. So that means the 12 lead, it's a 10-second continuous strip, but it's looking at the different camera angles during those 10 seconds, okay? So every channel's got about 2.5 seconds worth of data on it, okay? Not the 3 seconds, it's about 2.5 actually. So let's see here. Let's switch to the next one after I erase all my ink on my slide. And we'll go to here. And so kind of put some black lines there. So you got to understand what you're looking at. Again, these guys right here, these are our bipolar leads. All these three here, these are the bipolars. Oop. If I can go to the right one there. There we go. So again, in data column 1 here, this is our bipolar leads. And if we move it from the bipolar leads, these are the unipolar leads. All the unipolar leads, guys, have the A in front of it, okay? That's kind of your way to remember it. Bipolar, again, 1, 2, and 3. Augmented leads or unipolar leads. And then the 3 and 4 is your precordial leads, okay? So you got to understand what you're looking at. And we're going to go into, when we actually start reading the 12 lead, where each of these come into play as far as what part of the heart that they happen to be involved in. So one of the cool things about doing it this way is that I can look at, let's say, the P wave, and remember, the P wave is going to correlate with this guy down here. So if I really can't tell if it's AFib or not, I can take a look at another camera angle. And maybe that different camera angle is going to show me something different to where I can detect, oh, yeah, this is AFib. Oh, this is a flutter. Oh, this is SVT. Oh, you know what? I couldn't see the P wave on that one, but boy, I can see it really well in lead V2. So these are things that you got to remember to look at when you're looking at your 12 lead EKG. Again, it shouldn't mess you up at any point. You really should not. Now, again, there's simultaneous recording. The last 3, these are in line. Again, they pick whatever lead that they want to have here, okay? It can be any, they can preset it, guys, anything. They can set it to AVR if they wanted to. Kind of useless, but they could do that. All right. So with that being said, what is it that I need to know about this particular strip? And this is kind of what our common we get, but these are the things that you really need to pay attention to. And that those attention to is, you've got something that's got all your measurements in here, okay? And I think that that's very important. You got your PR interval, you got your QRS. And we've already talked about it a little bit, but I'm really going to go into it really deep about why that QRS axis is going to make a huge difference. Because this is going to tell us exactly where it's originating from and the path that the electricity is traveling in, especially in the ventricle. Okay, so again, we can tell a lot of damages that are going on, or not maybe necessarily abnormalities, but certain syndromes that happen because of that QRS axis. And we've talked about that a little bit with the hexagonal system in that first video, and talking about, again, a normal, again, is going down here, and the normal is 60, right? Which is lead 2, which is why we like it so much to kind of take a good look, our first look, I should say. Now, as you get better at EKGs, by the way, you're going to learn that lead 2, you have no clue. And what I mean by that is that lead 2 is great for an initial, let's figure out what the rhythm is, but then it's not necessarily good for telling everything out. One other little note here is the QT and the QTC, okay? Use the QT, guys. The QT is your true reading from, again, the start of the Q wave over to the end of the T. Okay, so the QT is kind of the number you kind of want to look at. This one's always probably going to be a lot longer, and if you make a mistake on that, it can kind of cause some problems for you. So converting measurements. Again, if I pull that little thing up again, a lot of the things that I've been teaching you is 0.12 to 0.20 seconds, okay? So that's kind of why but again, milliseconds is fine. So if you get a machine that's telling you 108 milliseconds, that we're fine, because again, the normal is what, 0.08 to 0.12. Okay? So that's your normal for this guy right here. Okay? So this guy's got a normal one. Most every EKG machine that I know does a printout of this, and so again, it gives us a good point of reference where I can tell this. Well, Scott, why did I have to learn these numbers when I was looking at strips? Well, the reason is because you got to know exactly what you're looking at, and if the machine doesn't give it to you, you have to be able to figure it out. Now, I've kind of stressed this already, but if I haven't stressed it enough, I'm going to stress it again. The machine gives an analysis. Now, if you talk to the guys from Physio Control or any machine manufacturer, their simple statement is it follows an algorithm and it's 98% correct. I've got a bunch of strips that I can show you that no, that's not true. The machine is built to interpret an algorithm, is just it. It analyzes data for a conclusion where people interpret the ECG, okay? Because, again, if the machine read it wrong, it's going to give you an erroneous reading, okay? And it might do that, okay? Now, the only thing I will say in their defense, if it says a STEMI alert, especially the Life Pack, the Physio Control stuff, if you've got that big message up there and it's got stars all over it, that one's actually pretty accurate, okay? However, it's not 100%. So again, you've got to look at it and make sure, okay? Acute care providers have to be able to tell what's on these strips. Now, the isoelectric line and the calibration. The calibration, I think, is kind of a big one here. All right, so the calibration. Notice that the calibration starts and begins the isoelectric line, okay? And that's kind of a really important point to point out, all right? And by the way, it's always going to go from there. It's going to go up to 1 millivolt above and then go back down as its calibration wave, okay? So again, usually you can find that if it's above that calibration wave, you usually have some sort of hypertrophy, okay? In other words, you got bigger muscle than you should have, all right? So keeping that in mind kind of puts things in perspective about where they should be. And it's usually found at the bottom of the calibration bar is where your isoelectric line is. So if you draw the line from there to there, as you notice, boom, there's your isoelectric line. And that's where you should be doing your measurements off of, especially when we start talking about the goal ST elevations, ST depressions, all right? Because sometimes it can get a little bit tricky. Now, how do I validate that I've actually put it on right? Again, usually your limb leads are the culprits. And again, they need to you just got to make sure that you got it on. If you look at lead 1, guys, lead 1 is almost always typically upright, okay? Lead 1 is going to be 99% of the time it's going to be upright. Okay, there's only one other place that I know that it's not upright, and that's when you got a VTAC situation, and we're going to learn that down, down, down is bad when we talk about that first column of data. So again, usually double check. Now, see, notice how the P wave is upside down. The T wave is upside down. By the way, in VTAC, your T wave will probably be right side up. Okay, so again, everything's upside down. Guess what? You put the leads are wrong. Okay, you gotta double check your leads. Okay, because more than likely that's what's going on. Now, for your precordial leads, we kind of use something called progression, and this is how we should see a progression happen. Notice how V1 really low, V2 a little bit bigger, V3 a lot bigger, V4 really bigger, 5 getting bigger just a smidge. But look at it, guys, if you think about it, where the muscle is, okay? So V1 and V2 are up here, okay? V4, V5, V6, and 3, of course, is in between. If you stop and think about it, it's got to go through a lot more. It's closer to this guy right here, okay? And remember, the machine only reads the amount of voltage towards the positive pole. So again, depending on where the negative is, it's only going to read it up to that point. So again, it's going to start small here and get bigger. Now, that's not always the case, but most of the time, and look at the difference here. So I got V1 that's kind of short, really tall, really tall. Wait a minute. Something ain't right. So if we follow normal progression, this guy should be a little bit taller than V3. Okay, so I would at this point double check my leads because again, can it happen that way? Yes, it can. Is it rare that it happens that way? Yeah. The first thing I would do, check my leads. As dumb as it says, one of the first things I do when I'm telling somebody to troubleshoot a computer, hey, did you turn the power on? As dumb as it sounds, it is very much true. So the first thing I tell students when they're checking a 12 lead is did you put the leads on right? Okay. If I'm not seeing a good progression, I'm going, wait a minute. Okay. Now that's going to end it for this. Again, these are little tips and tricks that I hope that will help you to understand that again, you got to make sure you're doing the right things. You got to make sure your wires are on right. And there's what is that little calibration box? So hopefully this will help you guys read your EKGs a little bit better. I will see you guys on the next one.